Morning is
Like build it up. Like this kid, my brother's class, like they're like stats like giving nuts like everybody's dad is Lee, dude, you're
I was gonna go ahead. I made it.
So he's like
Okay, folks. So you all have this. You can see it's a pretty long unit. So we're continuing trig. We have a couple quizzes. I haven't listed them here, but on your papers it says the first quiz is day 4 or February 26th. So it could on that day 4 it could be any of the previous day's material. And then there's another one on day 8. That could be anything from the day before, but probably mostly days 4, 5, 6, 7. And then our test is on March. Is that 19th? 19th. So a month from tomorrow. So lots to look forward to. So on the quiz last time, on our last quiz we talked about was tangent, and we're going to start today. See that? Oh, today we're talking about tangent functions specifically. Let me make this with this slide around. Oh, again, explanation here. So when it says Sullivan, do you know what Sullivan is?
It's like the guy who made it online.
Sullivan is the author of the book we use. And Pearson is it's the publisher of the book we use. So when I talk about Pearson, it's talking about the online portal, and I talk about Sullivan, it's talking about the book. So it's kind of interchangeable because we look at the book on the Pearson website. So again, in this unit, I'm going to try to do Pearson because I do like to be able to have a electronic record of it, but it doesn't always fit what we're doing. So like today, it's going to be from the homework packet. The homework packet, once again, will be on the hub. So I'm not going to supply you with printed copies of that. But I do have paper if you want to use it, if you don't have paper of your own. And to be perfectly clear, like tonight, it will be from the packet. You'll be doing pages 1 through 6. Pages 7 through 12 are extra practice for those of you like, can I practice this some more? But it's kind of a duplicate. So it's not like I want you to do pages 1 through 12. And when it's pages 1 through 6, that seems like a lot, but honestly, most people are able to finish it in class last period. So let's get through the new concept and get to the assignment, shall we? Let's do it. That gets read here. Let me set myself up for success. First page, you'll notice that in the box, how many of those equations are new? In the box on the top of the first page. Are they? The very first page.
Yeah.
All right, there are 3 equations. Are any of those new?
No.
The middle one's kind of new, but why does that make sense? Would you just check with your neighbor? Why does that make sense?
That's the Y.
Oh my God.
So M, of course, stands for slope. Does anyone know why they use M?
Is it a person?
I don't know. I don't know. I was generally asking. I don't know why. Variables are, yeah, that's true. I imagine S was taken for slope. S often represents position.
I feel like S would know.
But anyway, we know that M. Yeah, Tina? S, maybe S looks like a 5. Okay. Yeah, I don't know. I don't know.
Wait, I just have a theory here.
Oh,
What about
this is
M
not
for
gonna be good.
mountain? And like, you know how a mountain has a slope, so.
Wait.
I think that might be a nice mnemonic device. I like that. And then turn one of the humps upside down. Yeah, yeah. Thank you. Thank you. Namaste. Okay. In any case, hopefully you're familiar with the first and the third. I really like the second one, that tangent of an angle could be thought of as a slope of the which line? The what of the terminal side of the angle, the terminal side of the angle, right? Does that make sense? The y over x that. So in that first quadrant, here's kind of the start of a little animation that happens in your head. It starts at the left, goes to the right. This is the story of an angle traveling through the first quadrant, right? It's going from here to here. And I hope you can see that when it starts out, what is a tangent at that very first one? At the very first one. But what we've done is taken y over x before, but if we think about now as slope, maybe that's a quicker connection to say, yeah, that horizontal line has a slope that is 0. Do we know any of the slopes in the first quadrant? Like, do we know exactly what any of them are? I think there's one that's pretty easy in the first quadrant. Will you check with your neighbor which angle in the first quadrant is the easiest one to find the tangent of?
It's probably. Yeah. I think it's the third.
Looking at tangent of pi over 4, where the tangent, where the slope is 1, so that the tangent of pi over 4 is 1. Is that clear? And so you can see through this animation that in this third one, the tangent here is going to be more than 1, less than 1.
I would say it's on, but like, I think it's one.
Yeah, if it looks a little bit past the pi over 4, that slope is going to be a little bit more than 1, isn't it? Because, yeah, y is more than 1. Halfway is 1 because there's a y and the x coordinates, they're equal. So, and when you get past that pi over 4, then the y coordinate becomes larger than the x value. So, assuming like if this is pi over 4 right here, then the slope of this angle here, I hope it makes sense, would be a little bit more than 1. The slope of this angle, what does that look like? The slope appears to be maybe definitely greater than 1. Maybe 2?
I'd say probably like close to 3, right?
Maybe 3?
Oh wait, no, I think it's even higher.
I don't know. Perhaps what you're doing is imagining in your head this triangle here and thinking just how much bigger is that opposite.
How could it be 2? Because the power 4 is 45 degrees, and that's like 90 degrees.
Oh no, there's in between 45 and 90 degrees. There's a billion different angles. So we have an animation, we have all the angles. Like right here, we're looking at this one where this is definitely greater than 1. And you can see that the tangent of this angle,
That's like greater than 3. It's like going
it's pretty big. Is there a place in the first quadrant where the tangent is like 100? Is there an angle in the first quadrant where the tangent is equal to 100?
It could be that.
How about 1,000? Could be equal to 1,000? Where the adjacent side is 1,000 times bigger than the opposite side is 1,000 times bigger than the adjacent. Yeah. How big does it get? Infinitely large. Yeah. So if we're tracking the tangents in this, here the angle is here, the angle is here. If we're tracking the tangents going from 0 to infinity there, and there's one special place at pi over 4 where we know that it's equal to 1. Does this make sense right here? Please discuss with the neighbor what that means.
That's like website, that's right. Yeah, the very first one is everything works like side to like you'll start to get like
I never.
yeah, that's correct.
Okay. So who'd like to translate that into something a little bit more understandable, this idea right here. What is this saying? Yes, Simran. Are we good with that? Yes. Yeah, I think that's a perfect follow-up question. Like, is it really happening from the left? Well, normally we say x is approaching like some number dynamic from the left, but we're talking about something on a horizontal axis. But theta is an angle, and it's approaching pi over 2 from values that are a little bit less than pi over 2. So it's not really from the left, but from less than pi over 2. From a little bit less than pi over 2. So it's no longer up to the radian. Yeah, the angle measures approaching pi over 2 from the side that's a little bit less than pi over 2. So that's happening in the first quadrant. And as we were just talking about, that tangent is approach, or the tangent of that angle is approaching. Yes, Matt?
So if it was theta's pi over 2 positive, it could be going like that.
Yes, exactly. It would kind of be going in this direction. Is that what it's saying?
Yeah.
Yeah, exactly. Okay, some things we need to talk about. When theta equals pi over 2, the terminal ray is now vertical. The slope of a vertical line is undefined. In the materials, you're going to see D and E. Does anyone know what that stands for? Do not enter. It's not do not enter.
It does not exist.
Does not exist. Speaking of which, did anyone see Meatballs this weekend? Exact. Does not exist. So undefined or DM is acceptable. Okay, so when we go to the second quadrant, you can see that the animation continues here. And right here, suddenly, the slope of our tangent line, of that terminal side, how would you describe that tangent? Super negative, right? Super negative. And as it continues, it approaches 0. Right, we're talking about like this tangent here. So in this one that I'm highlighting right here, I hope it makes sense that that's going to be a very small negative number compared to this one right here, which is going to be a huge negative number. Big positive or tiny negative. Y over x, that's slope. Okay, so let's bring this all to any questions so far? What's going to happen once we pass that pi? Yeah, once our angle gets here, then what's going to happen to the tangent? It's going to be positive again, isn't it? In that third quadrant?
The same quadrant.
It'll be the same as quadrant 1, isn't it? Negative. And negative. Nice. In fact, if we look at this, the slope of this line compared to this one, those slopes are exactly the same, I believe. So, if my geometry is correct. So what we have here is a summary of all the tangent values as a function of x. Well, in this case, I'm looking at theta. But I hope that it makes sense that right here, and I'll put this in a different color. 0 to pi over 2, that's referring to quadrant 1, or 0 to 90. So do you see where quadrant 2 would be here? Pi over 2 to pi. I hope that makes sense. That's pi, that second, that's referring to second quadrant. Take the values we were just talking about and put it into a rectangular grid. So this is a graph of tangent. Will you please discuss with your neighbor what the period is?
Too hot. Where
Okay, what is a period? Does it make sense that it's pi? Okay. So we just talked about this region here. When we talked about going from first to second quadrant, but when we talk about a fundamental portion of the tangent, we don't normally go from 0 to pi. Instead, we go from asymptote to asymptote, specifically from negative pi over 2 to pi over 2. That's kind of the thing that you copy and paste when you're drawing your tangent.
like
But this is our numeric class. Has anyone studied tangent function before? You were Mr. Wu's class last week. I'm Mr. Sim. Nice. When you graph your tangent line or tangent graph, there are 5 things I want, 3 points and 2 asymptotes. Can you see what 3 points I want are specifically? Yeah, -1. Well, negative pi over 4, comma, -1, 0, 0, pi over 4, comma. Then the asymptotes. Just like any parent function, be transformed. The A represents, if we're talking about sine and cosine, that would be amplitude, but only sine and cosine have amplitudes. Right, it's the distance from that midline to the top. So I hope it makes sense that there is no amplitude for tangent because that would be forever. So A just represents vertical stretch or vertical compression. B represents horizontal stretch. Horizontal stretch compression. So nothing's changed. The convention that these materials uses theta plus C. I prefer to use theta minus C just because then it mirrors what we already know with parabolas and the other transformations. Just make sure you and then the problem. But C represents horizontal translation. Vertical translation. Oh. Yeah, of course. Yeah. Oh, yeah, just because I like to be consistent with all the other transformations we've done. I don't know why he did that. It kind of goes against everything I've learned in math classes, but it all works out because he makes the shift negative C. So like if you see like it's not a typo, but if you see something like theta plus 5, that means it shifted 5 to the left. So it's right, he's just changing it here. Yeah, so I'm sorry about the mixed messages there, but I'm sure you'll be able to get this straight. I have no doubt. Notice this period. Does that look familiar? Right, for sine and cosine, it was 2 pi over b, but for tangent, since the period is only pi, it's pi over b. Right, we take this b, that's the horizontal stretch compression by a factor of 1 over b, and then multiply that by the period. So pi over b. Yeah, Simran. Yes. Yeah, the answer won't change on the graph. So here's a graph, first graph. It's up to define A, B, and T. Sure. Yeah, that's one.
yeah, I got it. Bro, they're terrible.
Discuss with your neighbor. Okay, would you please show me what's happening with this graph from the parent function? I think there's only one thing, right? It's just being compressed horizontally by a factor of two, which means b is going to be 2. Yep, so compressed by a factor of 1/2. That's why b is going to be 2. So this is 2x, and I'll get your question in just a second. So this is 2x. And how do we know it's not being compressed vertically? Because well, so none of them could be compressed vertically or stretched vertically? Just where you write it, perhaps? I think there is enough information. Did you remember the 3 points? One of them is right here for sure. How do you know the other two? Well, think about where the other single point is. And in between this and this is just at 1. If that would have been up at 2 or down at 1/3, then there would have been either a stretch or a compression vertically. But because this is it's right here, this one, it matches this. Right in between that 0 and the asymptote. However, for in this case, it's up at 1. So the analogous place on this graph, right in between that 0 and the asymptote. However, 18, it's just up 1. If it would have been something like this, then we'd have a different situation. And we'd be able to see above this that, oh, that's a 2. It's going to be a vertical stretch. There's no vertical stretch here. And you'll get it. If you're not exactly sure right now, sure. So is A 0? It's a good question. A is 1. Yeah, I mean, there's no vertical stretch. Yes. Yes. Yeah, here it would include both because vertical asymptotes and that point. Any other questions? Yes. Is D the what? Correct. D is not a vertical asymptote. Let me finish this. So A is 1. I'll put 1 there. D represents. There's no midline for this, but kind of the line that's going through that middle. I guess. Yeah, it's a vertical shift, and for our problem there is none. So we just have f of x equals tangent of 2x. Are we good with that? I forgot to mention over here one problem here. Let's write where the vertical asymptotes are. How many vertical asymptotes are there? Infinitely many. So what I'm gonna do is not x equals, but I'll say theta equals, and this is vertical asymptotes, happen at theta equals pi over 2 plus makes sense to say integer multiples of pi. Yeah. Okay, so the vertical asymptotes happen either at the top or at the bottom. Do you agree with that? So think about the angles that have to be the angles that make those points. So here is pi over 2. It's gonna work. Come on. Okay, there it is. And the next one is pi away, isn't it? So plus 1 pi, plus 2 pi, plus 3 pi. So when I say pi k, that's k represents integers. Remember the symbol for integers? Remember the symbol? Yes, it's not I. It has a double staff. Is it what? It is a Z. Nice. Hard time writing this. Okay, so that's a little. Does anyone know what this symbol means? It is an epsilon. But this is an element of K is an element of real. So it just means that K is not real numbers. K is an element of K. K is an integer. Any questions? Oh, so thank you. Yes. Well, not from the origin, but from the twisty. Correct. And period could be measured from asymptote to asymptote, but really it could be measured from 0 to 0. Any place where it's so. I do love to work on examples 2 and 3. Okay, for example, 2 on the count of 3, let me hear the period. 1, 2, 3. Pi over 2. Yeah, are we good with that? Yeah. Remember, it's just taking that 2 reciprocal and multiplying it by the period. So pi over 2. Which one is it? A, B, C, or D? C, are we good with that? Is it really C? C is pretty close, but there's a problem, isn't there?
What?
Yeah, it's saying where K is a constant, which means K could be any number. Is that true? right? So it could be plus 3 pi times like 0.1. So is there a correct answer here? Like, what would you do if this were a test? Yeah, so using your best judgment, what do you do? So you would do this?
No, I would divide by.
Would that be good judgment?
Or you can just get over the one.
Would that be a good judgment? And then choosing this? Because the rest is correct. The rest is correct.
We know that. But it might have to be one.
Yeah, let's talk about why C is right, and then well, first let's talk about once you've identified a correct answer, but there's nothing weird about it. Like here, there was no correct answer. So you can either change the question, the option to say integer now is correct, or what's another thing you could do using your best judgment?
No.
What's that? Or just don't answer it?
No,
No, don't answer it right. All of these are wrong.
So all wrong, something like that?
You have all. Yeah.
Yeah, that takes confidence. Yeah, remember the point of the test, even multiple choice, I want to see what you know. So if none of them are correct, to say, I think the answer is this. So I can't choose one of the other ones because they're all wrong, but tell me what you know is true. So don't just leave it blank, of course, that'd be very poor judgment. Or I'd say it's okay to actually change that answer because it seems like with integer, they just forget. They forgot. And it looks like integer, there's lots of problems with this, but integer. Yes. Oh, it's the same question you just had. It's interesting. So this B, we take that horizontal, just take that factor, take the reciprocal of it, multiply it by the period. So we took the 2 and made it 1/2 and multiply by the period. Judy and then Max. Oh, good question. Well, let's talk about why it is option C. And when we think about this x over 3, we could rewrite that as 1/3 x. Does that make sense to think about it like that? Which means to find the period, period is going to be equal to well, we take the reciprocal of that 1/3. So 3 times pi. Yes. So our fundamental wave, like this is the first one. It's being cut in half. So instead of going from 0 to pi over 2, like if this whole thing is 3 pi, then I hope it makes sense that this is 3 pi over 2. Why now? 3 pi over 2, and this is negative 3 pi over 2. Yes? Or we could take our original pi over 2 and pull that out by a factor of 3, and to be multiplied by a factor of 3. So that's where this came from, 2 pi over 2. And it's plus 3 pi k because that's a period. 3 pi is a new period. Any questions? Yes, Nathan.
Would it be wrong if it instead of 3 pi over 2 has pi over 2?
Well, if this is our function, then that would be incorrect. And if you put a pi over 2 right here, there's not going to be an asymptote. But if you put a 3 pi over 2, there will be an asymptote there. And you'll put both these together, I'm sure. Well, let's work it out. And Simran, then I'll get your question after. So 2 times tangent of, and I'm going to think about this as 1/3 times x. Okay. So the question is, why isn't there an asymptote at pi over 2? Well, if I plug in a pi over 2, this gives me tangent of pi over 6. There's a slope there. If I plug in 3 pi over 2, what are we left with here? I think the threes cancel, leaving us with tangent of pi over two, tangent of pi over two. It's undefined there. So that's just how it works out. Good questions. Simran, do you have a question?
I am really what that is. There's a, if you have to see on, is it a swamp?
I think we just have to go back to, this b right here is a factor inside the function. When it's inside, we always think that what's happening is opposite of what you'd imagine. So instead of being multiplied by a factor of b, it's being multiplied by a factor of 1 over b. Just like with sine, just like with cosine, just like any of our parent functions. Yeah, what's the period of tangent? It's pi. So that's what's happening.
For everything.
For all tangents, it's going to be pi over b. Absolute value of that. Yes, Chloe? Perfect. Yes, this is the first asymptote. I like that clarifying question. But that's the first asymptote. Why is it 3 pi over 2? Because the original is a pi over 2, then it was multiplied by a factor of 3. And then all those are now 1 period away from that. So that's why I count multiples of 3 pi. Yeah, that should have real meaning to you. So thank you for helping me dissect that. Any other questions? Perhaps your question is, can we start on the assignment? If so, the answer is yes. Yes, you can. Oh, the answer would just be no for the other ones. No. Nice child. I'll post the first two pictures. First two pages.